Okay, so we are on Unit 8 and we're doing Day 4, and this is solving equations with logs, which is a little bit strange why we're solving equations with logs, but what happens in that all these equations, they become quadratics, and then we have to solve for x in the quadratic, and so we have different methods. Now we can factor, we could complete the square, or we could use quadratic formula now that you know all three methods to solve, and you can pick on which one you would like to do, okay? So it's kind of a mixed day. We can use whatever method you want. All right, so here we go. It says when solving log equations, remember that the base b, the number n, cannot be negative or zero. Be sure to check your solutions in the original equation. So we'll have to be careful, okay, with logs because they have what they call a restricted domain. Okay, remember that y-axis is their asymptote and they're not allowed to graph there. So any value of x that was 0, we would have to reject. Okay, and we don't go to the left of the asymptote. There's no graphing over there in log equations. And so therefore, our number or our base cannot be negative either. All right, because that's on the other side of the asymptote. So here we go. It says solve the following equations. Okay, and so because we are in log form, we remember that sometimes log form is not helpful to us. Okay, and in this case, our log form would not be helpful to us because we could rewrite it as the log of 16 divided by the log of x plus 3, but we can't put that in our calculator with the x there. And so what we're going to do is we're going to get out of log form. Okay, remember that the only reason why log form is good is because it helps us solve for exponent, okay, which is this spot right here. And so if you look in our equation, notice we already know the exponent is 2, so logs are not helpful to us. So we're going to go back to our exponential form, okay, b to the e equals n. And so remember our base is the little subscript there, which is x plus 3. And when I rewrite it, I'm going to use parentheses because I know the base is going to get raised to an exponent of 2, and I want to make sure that that exponent of 2 is on my entire base of x plus 3, equal to my number, which is 16. Okay. We know that you could go ahead and square root both sides, and this process comes from completing the square when you have an x plus 3 all squared, that you could go ahead and square root both sides. One thing that you have to remember, though, is that it's plus or minus the square root of 16. Okay. And what's nice about this one is that the square root of 16 is actually perfect. And so we could rewrite it as x plus 3 equals plus or minus 4. Okay. And then we could go ahead and do our last step in solving, which is to subtract the 3. And remember that it goes right in between. Okay. And so we end up with x equals negative 3 plus or minus 4. Okay. And therefore, one of our answers is x equals negative 3 plus 4, which is a value of 1. And our other answer would be x equals negative 3 minus 4, which is an x value of negative 7. Okay, and so now we're going to take our two answers and we're going to go ahead and we're going to double check them. Okay, so if I take my one answer of 1 and I plug it in for where x is, that's the log, okay, with a base of 4 of 16 equals 2. And 4 to the second is 16. And so this one checks out. Okay, also if you rewrote it as log of 16 divided by log of 4, you could type that in your calculator and out would come 2. Okay, so that would be a great way of checking. So now we're going to go back and we're going to replace that x with our other x value to see if it checks out as well. And our other x value is negative 7. And so that becomes log of negative 4 of 16 equals 2. And if you check it this way, negative 4 raised to the second is 16, as long as your negative 4 is in parentheses. However, rewritten, it would be the log of 16 divided by the log of negative 4. And if you type that in, it's going to give you an error. Okay. And therefore, we're going to go ahead and reject this. Okay. The base here is negative. All right. And we cannot have the base or the number position be negative or 0. And so that's why that gets rejected. And we type our one answer of x equals 1. Okay. All right, guys. Number 2. So remember that ln is a log. It's called a natural log. It has a base of e, okay? And in this one, remember that this is our exponent, and we already know that it's 0. So log form right now is not helping us, okay? So what we're going to do first, though, is we're going to replace the ln with log with a base of e. so that now we have a base, an exponent, and a number, and we can switch out of log form and go back to exponential, just like we did in the last problem. So this would be e to the 0 equals 2x squared minus x. Okay, well, e to the 0 power, anything to the 0 power, is 1. And so this becomes 1 equals 2x squared minus x. And I think you can see that we're going to have 3 terms and turn this into a trinomial. So we'll have 2x squared minus x, and we're going to bring our 1 over, so it'll be a minus 1 and will be equal to 0. All right, so now what we can do is we have a couple options. We can try to factor this. We could do the quadratic formula, or we could go with completing of the square. Okay? I'm going to try factoring just because I think factoring is the quickest if I can find the numbers that work in both, okay? If we can't find the numbers, then we'll go to quadratic formula. So our multiply, and I'm going to put my sad face here because this is a hard trinomial, okay? So our multiply is actually -2, and our add is -1. The only two numbers that multiply to 2 are 2 and 1. And to get a -1 out, this would have to be negative. So now make sure you double check your numbers now that things might not be factorable. So if I multiply them, it does work. Okay, -2 times 1 is -2. And if I add them, -2 plus 1 is -1. And so this is factorable, but remember, it's a hard trinomial, okay? So the 2x squared gets rewritten, then the -2x, then the +1x, then the -1. If we group the first two, group the last two, we could pull out a 2x and be left with x minus 1. Out of the second one, we pull out a +1 and left with x minus 1. So one of our factors is x minus 1. The other is 2x plus 1. And when we do our t-chart, we end up with x equals +1. And over here, we would subtract 1, so our 1 would be negative, and then we'd have to divide by 2. And there's our two answers, and we just have to go back up and make sure that this number position with the x's in it here doesn't turn negative or 0. And so we're going to have to carefully plug in. So we would do 2 times our answer of 1 squared minus 1. Okay, 1 squared is 1, and 2 times 1 is 2 minus 1, which is 1. And so this spot right here becomes a 1 when you plug in 1, and that would be okay. The ln of 1 is 0, and so that checks out. So we can keep this answer. If we go ahead and we do the same thing with our -1/2, this would be 2 times -1/2 squared minus -1/2. Okay, -1/2 squared actually turns out to be a +1/4. Okay, and 2 times a fourth minus a -1/2 gives us something that it gives us 1. Okay, and so again, ln of 1 is 0. Both answers gave us 1 when we plugged them in. So that is okay. So that checks out. Both answers can stay in this one. Okay. All right, so let's try number 3. And in number 3, we are in log form. However, we know the exponent is 1, and so log form isn't helpful to us. So we're going to get out of log form. Okay. What we have to realize is that right here, when there's no base written, that it's a base of 10. That's what they call a common log. And so now we can get out of log form now that we see our base exponent and number. And so it would be 10 to the first power equals 2x squared minus 5x plus 3. We know 10 to the first power is really just 10. And we also know that we need to be equal to 0, so the 10 needs to come on over. And so we're left with 2x squared minus 5x minus 7 equals 0. Okay, and now that we have our trinomial, we could do one of a couple things, right? We could factor if we can try to get the numbers and have it work. If factoring doesn't work, we have plan B, which is complete the square, or plan C, which is quadratic formula. All right, so I'm going to go ahead and try to factor. Again, I'm going to give this a sad face, okay, because that's a hard trinomial and there's no way out of it. So our multiply becomes -14 and our add is -5. Only two numbers that multiply to 14 and possibly give me a 5 are 7 and 2, and 7 would have to be negative. That's going to check in the multiply to -14, and it's also going to check in the add to -5, and so this is factorable, and I'm going to go ahead and factor it. So again, sad face. Hard trinomial, more work. Okay. I'll put the plus 2x first, then the minus 7x, then the minus 7. And I group the first two, group the last two. Out of the first group, pull out a 2x, left with x plus 1. Out of the second group, it's got to be a negative, and it's going to be 7, and left with x. Flip the sign because you pulled the negative out, plus 1. And we end up with one factor of x plus 1 and a second factor of 2x minus 7 equal to 0. Okay? Do a little teacher, and on this side, our solution will be -1, and on this side, our solution will be x equals, you would add the 7, so 7 would be positive, then you would divide by 2, okay, which is the same thing as 3.5, okay, if you like 3.5 better, all right? We have to go back up and plug in our solution of x equals -1, okay, and when we plug in a -1 up here, and we type it into our calculator, this comes out to be 10. And 10 is not positive and it's not 0, and so my -1 can stay. Okay? And now I'm going to go ahead and replace my -1s with 7/2, which is 3.5. So 3.5 might be easier to type in. And when I hit enter, I also get 10. And that's not 0 and it's not negative, and so both answers can go ahead and stay. Okay. All right, let's take a look at number 4. Again, it's in log form, and that's not going to be helpful to me because I already know that the exponent is this 2 right here. And the logs are supposed to help me solve for the exponent, and so when I already know the exponent, I don't need logs. All right, so we're going to get out of log form, and we're going to go back to exponential form. Okay? And when we do, I'm going to write my base first, which is x plus 3, but I'm going to put it in parentheses because it's raised to the exponent of 2. Okay? Equal to this lovely fraction of x cubed plus x minus 2 all over x. Okay, it's a funky number. All right, so unlike the first one, I don't think I want to square root this, because if I square root that, I'd have to square root the other side, and that kind of looks messy. So what I'm going to do instead is I'm going to do x plus 3 written out twice. Now that it's written out twice, I can go ahead and put it together. So this would give me x squared. This would give me 3x, but so would that. So for a grand total of 6x, and then 3 times 3 is 9. The other side has stayed the same. Okay. What I'm going to do now is I'm going to put this side over 1 so that I can do something called cross multiply. Okay, fraction equal to a fraction. When that side is being multiplied by 1, it stays x cubed plus x minus 2. Equal to this cross, and you got to multiply every term by x, so that would turn that into x cubed. That's going to turn that into 6x squared, and that's going to turn that into 9x. Now, if you take a look, you got 3 terms on one side, 3 terms on the other side, and we have to get them all together. Remember, you always want your square term to be positive, and so we're going to leave the squared term. In fact, we're going to leave these 3 terms here. Okay, we're going to bring these ones over. So we'll subtract x cubed, and you're going to see something that cancels, which is awesome. Okay, you're going to subtract x, but make sure that you put it under the 9x. They're the like terms. Okay, and then add 2 and just tack that onto the end. Okay, so when we're finished bringing over our terms, we're still left with a 6x squared. But 9x minus x is positive 8x, and then plus 2. And don't forget we're equal to 0. Okay. All right, so now that we finally got our trinomial, we could do a couple things to solve it, right? We could factor it if it's factorable. We could use completing the square or quadratic formula if it's not factorable. Okay. At this point, you could pull out a 2. There is a greatest common factor of 2 if you're trying to factor it. So if we pull that 2 out, we would be left with 3x squared plus 4x plus 1 equal to 0. Okay. And now we can take this trinomial, which I'm still going to give it a sad face because of the 3 still there. It still makes it a harder trinomial. But our numbers are smaller. Our multiply has now become a 3, and our add is a 4. And the numbers that do the job are 3 and 1. Okay? And 3 plus 1 is 4, and 3 times 1 is 3. And so it works in both. And so this is factorable. Okay? I'm going to just drop this 2 down. Okay, and I'm going to spend some time in here factoring this trinomial. So we got 3x squared. I'd probably put the plus 3x next, then the plus 1x, then the plus 1, and we're equal to 0. Okay, group the first 2, group the last 2. Out of the first group, we can pull out 3x and be left with x plus 1. All right, out of the second group, we can pull out a positive 1 and be left with x plus 1. And so that becomes x plus 1 is actually our second factor because 2 is our greatest common factor is the first factor that we dropped down, okay, and the 3x plus 1, and we're still equal to 0. Okay? So now that we've factored, we can go ahead and solve. When we set our factor of 2 equal to 0, there's no value of x, and so there is not going to give us any solutions, which is fine because our two solutions are going to come from these two factors. One of them is negative 1. In this one, we would subtract 1, so our 1 would also be negative, and then we would divide by 3, so we would get negative 1/3. Okay? Remember, though, we have to go back all the way to the top, and we have to check our answers. Okay? What stinks about this one is there's actually 2 spots that we have to plug our answer into, so that's a little bit on the messing side. Okay? But if we take our answers and we plug them into our base, which is the x plus 3, that ends up being negative 1 plus 3, which is positive 2. So that one can check there. And when we take our other answer of negative 1/3 and we add 3, that's not going to give us 0 or a negative number. And so far, the base position checks out. Okay. So now we have to go ahead and check our answers into here. All right. So now we end up with negative 1 for our answer, raised to the third, plus negative 1 minus 2, all divided by negative 1. So remember to hit enter after you type in the top, okay? Then divide by negative 1 and hit enter. And this is actually going to check out. That position is not negative or 0, okay? So then we have to take our other answer of negative 1/3 and plug that in. And we'll type that in. We'll hit enter. We'll divide by negative 1/3, hit enter, and that is not 0 or negative either. Okay. And so both answers going back down can stay. Neither one is going to get rejected. Neither one makes the base position negative or 0, nor the number position negative or 0. Okay. So both answers would work out in the original equation. And that is the end of those days of notes. Okay. So I will see you guys on the next video.